In this video, we're going to take a look at polar coordinates and then use those polar coordinates to sketch curves. So the first example I have is to sketch the curve of r is equal to 3 sine theta. And it's important to remember that with polar coordinates that our parameters are theta, which is our angle, and r, our radius, instead of x and y. So when I want to sketch the curve of r is equal to 3 sine theta, the first thing I'm going to do is sketch r with respect to theta. So if we have r is equal to 3 sine theta, so for 3 sine theta, the range is going to be -3 to 3. So I'm going to mark off down to -3 and up to 3. And then here, we're going to have a period of 2 pi. So we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. And sine starts at 0, so we're going to start off at 0. And then at pi over 2, 3 sine is at 3. And at pi, 3 sine is theta is back at 0. At 3 pi over 2, 3 sine theta is -3. And at 2 pi, 3 sine theta is back to 0. So we have a curve that looks something like this. And now we're going to use this graph to draw r is equal to 3 sine theta. So here how we plot points is that when our theta is 0, our r was 0. So we're starting at 0, 0. So this point here relates to this point, A and A. And then when we want to sketch pi over 2, remember these were increments of pi over 2, we're at 3. So pi over 2 is at 90 degrees. And then we're going up to 3. So 1, 2, 3. So this is point B, which is this point. And now our next point at angle pi, we're going to be back at 0. So here point C is also point A. So C and A are the same point. And then at 3 pi over 2, which is down the vertical, we're at -3. And if the radius is negative, then you're going to go the other way. So if the angle is 3 pi over 2 and we're -3, that puts us back at B. So B, and we'll call it D, are the same point. And then at 2 pi, which is also equal to 0 as far as the angle goes, we're back to 0. So this is E. So we can see that these actually double back over each other. It creates a circle now. So we have a circle that goes in this direction. And remember that it's also important to mark direction with parametrics. And for this particular curve, we could only graph half of a period because from A to C we drew the circle, and then from C to E the circle just doubled back over itself. In the next example, we have sketch the curve of r is equal to 3 sine of 2 pi. So here for 3 sine of 2 pi, our period is equal to 2 pi divided by 2, and we got the 2 from the coefficient that is inside with the theta. So here we have a period of pi, and again our range is going to be -3 to 3. And now we're going to still sketch to 2 pi, but we have to remember that that's going to be 2 periods worth. So this first mark I have is going to be pi over 4, and then pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So we're in increments of pi over 4. And I'm strategically picking these increments so that it helps me graph this easier. And pi over 4 will help because with a period of pi, every pi over 4, we're going to either hit the axis or we're going to hit a max or a min. So at 0, we're going to be at 0. At pi over 4, we're at 3. At pi over 2, we're back to 0. At 3 pi over 4, we're at negative 3. At pi, we're back to 0. And then we're going to be up at 3, back to 0, down to negative 3, and back to 0. So we're going to have 2 periods of 3 sine 2 theta. And most of these graphs you're going to want to draw for 2 pi, and sometimes you may need a little less, like our last example, and sometimes you may need a little more. But rule of thumb is that I usually draw 2 pi to begin with, and this was 2 pi. And now, in order to graph this, we're going to say when theta is 0, we're at 0, so we're starting at 0. So I'm going to put a mark there. At pi over 4, which is going to be, we can put like a dashed line if it helps. We're going to be at 3, so somewhere at 3. And then when we get to pi over 2, we're back to 0. So if we call this point A, this point B, and this point C, our mark at 0, 0 is A and C. This point here is point B, so we have something that circles in the first quadrant, and actually it looks more like an ellipse. Just remember when you're drawing these that everything is a curve. There's no straight lines when you're doing parametric curves. So we're here at C, and then our next point is 3 pi over 4, and we're at negative 3. So 3 pi over 4 is in this direction, but we're going negative, so we're actually going this way to 3, and now we curve it to here, and then the next point we're back to 0, 0, so we curve here, so we're back to here, 0, 0, and now the next point is 5 pi over 4, which would be in this direction, and then at 5 pi over 4 we're at 3, so we're going to go to 3, and we're going to curve this way. And then the next point we're at is 3 pi over 2, and we're back to 0, so we're back to the start. And then our last loop at 7 pi over 4, which would be in this direction, we're negative 3, so we're going to go 3 in the other direction, so we're up here. And now we curve up to that point and around. And ideally, these will look as symmetric as possible, and it was hard for me to get some good marks as far as scaling. So oftentimes you'll want to use a ruler or something where you can get some good scaling. So all of these loops are 3 in each direction, and the curves look as close as possible. So now curve loop 1 was this loop. Loop 2 was this bottom loop. And then this was loop 3, which is here. And then this was loop 4. And then if you kept drawing, it would just keep doubling back over itself. And that's how we sketch curves with polar coordinates.